Recording, excellent. I'm going to talk you through question 5 of the problem solving section of the homework. So we're told that jam is packed into jars and the weight of the jam is normally distributed with mean 460 and variance 25, and we're told anything under 454 grams is classed as underweight, and we're asked to find the probability that our jam jar chosen at random is underweight. So that is the probability that X is less than 454. So this is just an S1 type question here from the normal distribution that you've done before. We need to standardise. So moving from X to Z, we are going to do 454 minus the mean, 460, divided by the variance, the square root of the variance, so square root of 25, which is the probability that Z is less than minus 1.2. Probability that Z is less than minus 1.2 is this region here, which is the same as this positive region. The probability that Z is more than 1.2, which is the probability that Z is 1 minus the probability that Z is less than 1.2. And if we look this up in our table and subtract from 1, we get an answer of 0.1151. Now, in part 2, we are told that the jars selected randomly are packed into trays of 12. So when you've got a fixed number of objects in a tray or a pallet or something like that, you need to automatically be thinking of the binomial distribution because we're doing a fixed number of trials. In this case, the trial is checking the weight of a jam jar. And we're asked to find the probability that a tray contains no underweight jam jars. So our test is this jam jar underweight or not? We've just calculated the probability of a single jam jar being underweight. So we're going to let Y be the number of underweight jam jars. So if we're choosing them from a tray, Y will be binomially distributed. There are 12 jars in a tray, and the probability of the jam jar being underweight is our answer from part 1. And we're asked to find the probability that the tray contains no underweight jam jars. So that is the probability that Y is equal to 0. So that's 12 choose 0 times P to the 0 times 1 minus P, which will be that to the power of 12. And if you type all that in your calculator, that should be to the power of 0 there. That's 1, that's 1. So we just need this, and that comes to be 0.2305. We're then told in part 3 that 1,000 trays are taken to a supermarket. So it's still a fixed number of trials, but no longer are we looking at individual jam jars, we're looking at individual trays. So it's still a binomial distribution, but a different binomial distribution to the one in part 2. So we need a new letter. We've used X, we've used Y. We don't use Z because that refers to the normal distribution. So I'm going to use W, and it's going to be binomially distributed. 1,000 trays. And the thing we're testing is, does a tray contain any underweight jam jars? So we're going to say W is the number of trays that contain no underweight jam jars, and the probability of a single tray containing no underweight jam jars is 0.2305. So this becomes our new p-value, where W is the number of trays containing, my spelling's pretty bad there, I don't know what that letter is, containing no underweight jars. And that's our answer to part A. Part B, we're asked to find the probability that at least 250 of the 1,000 trays contain no underweight jam jars. So the probability that W is more than 250. And we're told to use an approximation. So we're going to approximate this to the normal distribution. Normally when you have a very large n value, we're going to choose normal rather than Poisson because they can be looked up in tables more easily. So another new letter, I'm going to choose V. V is going to be normally distributed with mean 1,000 times 0.2305, so that's 230.5, and variance 1,000 times 0.2305 times 1 minus that number, which is 177.37. So the probability that W is more than 250, we have to do a continuity correction because we're going to a discrete distribution. So that should be more than or equal to there because it was at least 250, not just strictly. So that's the probability that V is more than 249.5. We've done our continuity correction from discrete to continuous, which is the probability that Z is more than 249.5 minus 230.5 all over 177.37 square rooted. And if we type that in, we get the probability that Z is more than 1.42, which is the same as 1 minus the probability that Z is less than 1.42. And we would look this number up in our normal distribution and calculate it like that.